In section 4.5, we'll be learning how to solve compound inequalities. So compound means more than one, and we're bringing together two inequalities together, and we're going to make it into an and compound inequality or an or compound inequality. And those are your two goals today. So let me explain compound inequality first. So I'm going to start with and. And compound is when the two inequalities, and when you're solving, it represents the solutions for both inequalities. So if I have x, which is less than or equal to negative 10, and x is less than 2, I want these x values to meet both conditions. So when I graph this, I'm going to graph it as one graph instead of two, and we are going to put negative 10 here and 2 here. Now, to graph x is greater than or equal to negative 10, we're going to have a closed circle to include negative 10, and greater than means to the right side. So any number to the right of negative 10 is greater than negative 10. Now, to graph x is less than 2, so it says less than, so it does not include 2, so it's an open circle, and less is to the left side of 2. So when you graph it like this, they overlap between here. So any numbers from negative 10 up to 2 would meet both of these conditions. So that's why this is an and. And then to write this graph as an and compound inequality, we put it together. So all these numbers, which are x, so x, and that is between negative 10 and 2. And if you notice, negative 10 is less than or equal to x, and x is less than 2. So this together represents an and in compound inequality. So then or will meet either of the inequalities. So if I have x is less than negative 5 or x is greater than 1, I want these x values to meet either this condition or this condition. It doesn't have to meet both. So when we bring this together to graph on the same number line, we got negative 5 here and 1 here. Because x is less than negative 5, it's an open circle, so it does not include, and to the left of that negative 5 is less than side. And then in this one, it's greater or not equal to, so it's an open circle, and the greater the side, it will be to the right. So any numbers on the left side of negative 5 and right side of 1 would meet this condition. And it's either or. It doesn't have to be true for both. Okay, so that's why it's an or compound inequality. So now to write this, you just write it as it is given. So you will always use the word or in the or compound inequality, and this will be the graph. So if you notice, and the arrows point toward each other, or point away from each other. So they're in opposite direction, and this one toward each other, so they share the same shaded area. So the type of questions that you will see today in this section is, we're going to start with a word problem. And what we want to do is we're going to take the situation and we're going to write a compound inequality and we're going to graph it. So we're going to write and graph. Now this one is we're going to compound inequality that represents all real numbers that are at least negative 1 and at most 3. So like any word problem, we're going to define a variable. So we're going to pick a variable. I'm going to pick x to represent all real numbers. So this is x. That is at least. So now we've been learning about those magic words. At least means greater than or equal to, because this is a minimum amount. So greater than or equal to negative 1. So x is greater than or equal to negative 1. And the word at most, 3, means less than or equal to 3 because 3 is our maximum. So x is less than or equal to 3. So what I like to do is graph the situation first and then write the inequality. So on a number line, and remember least to greatest, -1 is here, 3 is here. Now this says x is greater than or equal to -1, so or equal to means including -1, and greater means to the right. And in this one, x is less than or equal to, so including 3, and we're going to go toward the left. And this region right here represents all real numbers that are at least -1 and at most 3. So now to write this as a compound inequality, we'll put the x in the middle, -1 here and 3 here. And if you notice, -1 is on the less than or equal to x, and x is less than or equal to 3. So this answer represents the situation. Let me give you one more example. All real numbers that are less than 31 but greater than 25. So this again is less than 31. This says greater than 35. And we're going to let all real numbers be represented by x. So x is less than 31, x is greater than 35. Okay, so then when we graph this together, we got 25. I don't know why I put 35, but this is 25. And here's 31. X is less than 31, so less than. And this one is x is greater than, so this way. And here's my x. So my compound inequality for this would be then x is greater than 25, but less than 31. Now next type that we're going to write is for the or. So the last example was for and, now this is for or. So we're going to write and graph the situation where all real numbers that are less than 0 or greater than 3. So same thing again. We're going to pick a variable for all real numbers, which is x, and that x has to be less than, so x has to be less than 0, and that x also, or, has to be greater than 3. So now if we pick these inequalities and graph it on a number line, I have 0 here, 3 here. X is less than 0, so this one, open circle, and the left side is less. And this one, x is greater than, to the right. And if you notice, the x's are on the going to the opposite side, so it's an or, and they give you the word or. So when you write this answer, you write it as x is less than 0. You have to include the word or, and x is greater than 3. And that's writing a compound or inequality. So now to meet our learning targets today, we have to know how to solve and or compound inequalities. So let me go to example number 2, and this time we're going to be solving and graphing. So here's my inequality. 5 is greater than 6 minus x, which is greater than 2. So if you notice, we have two inequalities here, and this is why this is called a compound inequality. And this one I consider to be an and, because there's no word and these are together. Okay, so we're going to consider it to be and compound. So now, like we did before, we're going to put a line through our inequality symbols, and our goal is to get x by itself. So to get this x by itself, the very first thing we got to do is get rid of this 6, and we get rid of it by subtracting 6. So then that will cancel. So then we have to subtract 6 here, but also over here. So we do it to both sides. So then 6 minus 6 is 0. 0 minus x is negative x. And then over here will be negative 1. And this will be negative 4. And remember, we're still solving for x, and we've got to get this x by itself. So to get rid of this negative, we're going to divide by negative 1. So we divide it to both sides. And negative makes it a positive x, and x is by itself. Negative 1 divided by negative 1 is 1, and negative 4 divided by 4 is 4. And because we divided by a negative number, we must flip the inequality. So there's my answer, where 1 is less than x, which x is less than 4, and this is an and when we graph it, it should be able to, the graph should be pointing toward each other. So when you read this, x is greater than 1, so open circle, x is greater than, so to the right. And this one says x is less than, the pointing end is less. And since they both go toward each other and they're sharing the same solutions, this is our and compound inequality for solving this. And the way to check is to write down the original and pick any number that is between 1 and 4. So we could pick 2, and when I plug it in, I'm going to get 4 in the middle, and we're going to check to see if 5 is greater than 4 and is 4 greater than 2, and it's true, so it checks. So we solved this correctly. The last type of equation that we're going to solve, which is example number 5, is to solve and graph, and this one is going to be for an OR compound inequality. This is an OR. Because they actually give you the inequality separately using the word OR in between them. So you got 3x plus 2, which is less than negative 7, or we got negative 4x plus 5, which is less than 1. So we're going to do them separately. We're going to come over here, draw our line, and then we're going to solve for x. So get x by itself. So subtract 2 first. So then 3x is less than negative 9, and then we divide by 3. So x is less than negative 3. We're going to come over here, draw our line, subtract 5 to both sides. We got negative 4x is less than negative 4, and then we're going to divide by negative 4, so that x is by itself, and then x negative 4 cancels out. X is 1 is over here, and because we divided by a negative number, we got to flip, and we're going to put the word OR here. And then when we graph, we got negative 3, I got 1, x is less than negative 3, so open circle to the left. This one is x is greater than, and if you notice, this is an OR because I go in the opposite direction. So this right here is my answer to this inequality.